So how do we fit all of this together? Well, we've come up with quite a remarkable story about how this can be made to work. And the idea is that although the differences in the early universe were very slight from one place to another, they were enough that gravity is a factor you have to include. So if you have a part of the early universe which has slightly more stuff in it than its neighbors, then there'll actually be a net force of gravity towards that part of the universe. And that will have the effect of sucking in material from the surrounding regions of the universe. So over time, something which starts out just having a little bit more stuff in it will get more and more and more stuff in it. And this is a kind of runaway process that, in the end, is able, we think, to build galaxies and stars and planets and the universe that we know and love. There's just a small price to pay for this beautiful picture of how the universe has got to its current state of affairs, which is that it works, but only if 95% of the universe is invisible. So on the one hand, it's an amazing success. On the other hand, it does invoke a lot of unknown quantities, which really the goal of cosmologists at the moment is to understand some of these unknowns. But let me show you how it works. I'm going to do this with some computer simulations that we ran. A lot of what we do in cosmology involves computer simulations. Essentially, we program the universe with some of the laws of physics that we think are relevant, in particular things like gravity. We tell the computer what the early universe was like, using things like the evidence from the Planck satellite. And then we more or less hit go and say, OK, show us how the universe unfolds. So if I hit go now, you'll see the Big Bang. This big ball of stuff is expanding towards you. We don't think that the universe has an edge to it like this, but when we put it into a computer, we can only run some finite little portion of the universe. So our computer model, of course, has to have some kind of edge to it. And you saw it expanding towards you. And now here we are approaching 2 billion years after the Big Bang. That expansion is just the overall expansion of the universe. And what you'll have seen so far is something that originally just looked like a green ball has turned into a sort of green web of structure. And that structure is what I was showing you earlier on. That's the cosmic web. Now, nothing much in space is green, so you might wonder why on earth this looks green. It's because we've asked the computer to project this in green for the simple reason that you could never see this view yourself. It's to sort of remind you that this is actually not something that you could see with a telescope, because what you're actually looking at is what we think the dark matter does at those early times. If I switch to a view that would be more like something that you could take with a telescope, the universe at 1.7 billion years old looks something like this. So you can see a lot of the features I showed you earlier on already exist. There are these big filaments, they've got gas in them, and they've also got little forming proto-galaxies along them, which already have millions or billions of stars living in them. So you can take a sort of flight through our little portion of the early universe here, take a look through what the various bits and bobs look like, and they just look like blobs, really. It's a lot of the galaxies that we think were there in the early universe are a bit blobby. Not all of them. Some of them are also beautiful spirals, like the ones that we're more used to seeing in images from the modern universe. You saw there the kind of scaffolding of dark matter that surrounds these galaxies. So that's really the need for dark matter, is to give the galaxy some kind of scaffolding. And it's actually a lot of the impetus that's drawing material into the little forming proto-galaxies that we see here on the screen. And if I restart time, you see what happens as time goes on. It's this process I was talking about a moment ago, that one small galaxy has the effect of pulling in all the neighboring galaxies, because it's just got that slight extra gravitational tug towards it. So surrounding little galaxies tend to get attracted into their slightly more massive neighbor. And if you watch what happens next, those galaxies progressively merge together and build larger and larger and larger galaxies. All the while, as this is happening, the raw materials like gas and dust within these individual galaxies are being able to form more stars. And so the total number of stars in our little portion of the universe is rapidly going up. And they would also be forming planets around them. We don't have computer models that are yet powerful enough to see planets form around the individual stars. Hopefully one day we'll be able to get there. But at the moment, all we can really say is that some stars are forming within our computerized universe. If I skip all the way forward to near the present day, you end up with this big swirling mass of gas, stars, and dust that if you fly into it, go all the way to sort of about halfway out to some insignificant spiral arm, you find somewhere that our own star, the sun, might reside. And then you can take a look at what the night sky in this computer universe actually looks like. And it looks at least a little bit like what our own night sky looks like. And all of that comes from starting with what seems to be quite an alien beginning to the universe, very small, very hot, and only very small ripples going through the universe. So we do actually understand quite a bit about at least what made what's inside our universe. And if you want to really answer the question of what made our universe as a whole, of course, you have to answer the question that's one layer deeper than that, which is, well, where did these ripples come from? And that's a very interesting topic that we'll have to postpone for the next time you vote for a cosmological topic. So for now, I just wanted to conclude by saying, even though all this can make you feel insignificant, or it certainly makes me feel insignificant, I think it is really a great privilege to be part of a human race that has taken the time and energy to actually look into all of this and piece together our own cosmic history and our part in it. So thanks very much for listening.